So hi guys, welcome to my channel. Today I am going to solve this problem of undirected graph cycle, which is the most famous problem in graph. Whenever you touch this topic like graph data structure, you will have to encounter this problem in order to solve further problems. So let's read this problem and try to understand what this problem is trying to say. Given an undirected graph with v vertices labeled from 0 to v minus 1 and e edges, check whether it contains any cycle or not. Graph is in the form of adjacency list where ADJI contains all the list of nodes, ith node having edges with. Okay, so the question is asking us to find the cycle to detect that whether the undirected graph has cycle or not. So in this example, we can clearly see that there is a cycle, like 1 2 3 4, then 1 2 3 4. This is a cycle. In this example, there is not no cycle, so we can see that output is 0 and this problem output is 1. So we are given the adjacency list, like this is the 0th index, so 0th node is connected to 1, 0th node is connected to 1. This is the first index, so 1 is connected to 0, 2 and 1, 1 is connected to 0, 2 and 4, sorry 4. So let's try to understand like what is the approach of solving this problem. So here I have drawn all the adjacency list, like which node is connected to how many number of nodes, and this is the visited array, like to track that whatever node we have visited we have to store in this visited array, so that it helps us to find that whether this cycle with this graph contains a cycle or not. So let's start iterating this. So first, by the way, let me remind you that this is the problem of recursion. We can approach this problem in two ways: BFS of DFS. In this video I am going to like explain this with the help of DFS, the first search. So DFS is all about recursion. So let's start. So we are starting from this node. So this is the 0th node and we will send the parent of this node. So as you all know that there is no parent of this node, so we will pass it as -1. Okay, so this DFS will call further, like from 0th node we have started, whatever node we can visit from 0th node is 1, so we will call it as DFS of first node, and what is the parent of this first node, it is 0, so we will mark this 0. This is the current node, let me write, and this is the parent node we are sending. So we have visited 1, we have visited 0, so we will mark 0 as true. Now we are currently at 1, we will mark 1 as true and visit next. From 1 we can visit 0, 4 and 2, but 0 is already visited, so we will not visit it one more time. 4 is not visited, so we will visit 4. So it is DFS of 4. And what is the parent of 4? 4th parent is 1, so it is 1, so we will mark 4th as true. Now moving further, DFS of 4 already visited. Up now let's see from 4 where we can visit. From 4 we can visit 1 and 3. 1 is already visited, so we will visit 3. So now DFS of 3 comma, what is the parent of 3, which is 4. Like moving to 3, we have to check, like from 3 we are visiting 2, no, 3 we have to mark this. Now 2 is not visited. From 3 we can visit 2 and 4. 2 is not visited, so we will visit 2. DFS of 2. What is the parent of 2, which is 3. So we have visited, we have to mark this as 2. Now from 2 where we can visit further, let's see, from 2 we can visit 3 and we can visit 1. From 2 we can visit this as 3, so DFS of 3. And what is the parent? What is the parent of it is 2. Okay, so parent is 2, but wait, there is a problem. Like we have visited 0, we have visited 1, then we have visited 4. Let me change this pen. We have visited 0, then we have visited 1, then we have visited 4, then we have visited 3, then we have visited 2. After visiting 2 we have two options, either to go on 1, either to go on 3. So we have visited 3, but one thing you have to notice is that we have visited from this, we have visited this, we have visited this, we have visited this. Now here comes the point that why we are maintaining the parent parent variable. Why? Because there is a possibility that after visiting to 2 we have two options, 1 and 3. We can visit again 3, but 3 is the parent of 2, so there is no need to visit it again. So we will not visit the parent again, so this call will not go. If we get to know that from 2 whatever node we are visiting, if it is the parent of 2, means from 2 we can, you can see that, you can see here, from 2 we can visit 3 and 1, but 3 is the parent. How we come to know? Here, from here 3 is the parent of 2, so we will not visit this. Okay, so next call will go this side. From 2 we have visited 3, we have to visit 1, so let's see, we will call this as DFS of 1. What is the parent of 1? Which is 2. Now again this is the here comes to identify the cycle. From 2 we have visited, we have options to visit 1 and 3, but 3 is the parent of this node, so it is obvious that it will be visited already. Visited of 3 will always be true, because from here only we have reached to 2, but after 2 if we visit 1, so it is already visited, because from here we come to 1, then come to 4, then come to 3, then come to 2, and 3 is already visited. So we 3, the node 3 is in danger, so we have when we have checked that 3 is already the parent of 2, so we will skip that node. 3 is not the danger. Now coming to next, when we visit 1, we see that 1 is already visited, so we have to check that whether 1 is the parent of 2 or not. If 1 is not the parent of 2, then there must exist a cycle, because 1 is also not the parent of 2 and 1 is already visited, so this is the condition of cycle, so we will return true here. So this from this node we have detected that this cycle, this graph contains cycle. So let's code it. Okay, so we already got the adjacency list, so we are just directly making the visited array, or say visited map. Now we are traversing all the nodes. If the current node is not visited, then we make a call visited of I not equal to, then we make a call like and DFS of I comma first, when when we have started traversing this first node, we have sent the parent as -1, because there is no parent of this first node, so we will pass the parent as -1 comma j comma visited. And if visited is not true, and also there is a cycle, then we will directly return true, means yes, there is a cycle. Okay, and at last, if the for loop gets over and we haven't identified that, we haven't detected that there is a cycle in this particular graph, so we will return false. Let's write the DFS code now. Bool, it is a type bool DFS and u parent, then we have passed adjacency list now, adj this comma visited map, or say array. You can also create a visited array. Now our first step is to, whenever we are trying to visit any of the node, we are marking it as visit. So visited of u is equals to true. Then what we are trying, after marking visited equal to true, we are trying to see that, okay, this node is marked true, then what are the adjacent nodes we can visit from this node. So we will iterate a for loop, auto v adj of u, auto this adj of u. Now all of the nodes from where we can visit, like this stored in v, and now we will check that if v double equal to parent, like we have visited the parent, so we will continue. means we don't have to do nothing. You have to move to next node. Else, if v is not the parent and if visited of v double equal to true, or you can just visited of v also, then return true. Why? Because v is also not v is parent, so we will directly continue. If v is not parent means v is not the parent and v is visited, so we will directly return true. Next we will check that v is not the parent and v is also not visited. If a node is not visited, so we will make a call like to check further nodes. So v comma parent is u and comma adj comma visited. If this is true, then return true, because let me explain. Okay, so let me explain. If v is parent, then we will simply do continue. Let me explain from here. If v is parent, like if let's say this from u is this, v is this. If v is parent, then we will u is this, v is this. So if v is parent, then we will directly skip this node. From here we can see that 2 we have visited, 3 is parent, so we have skipped this node. Now coming to next node, 1 is not the parent. We will go to second if statement, then check if 1 is visited. Yes, 1 is already visited from here and 1 is not the parent, then there is a cycle. We have returned true. What if 1 is not the cycle? Then we will call next, like from 1 we call that dfs of 1 comma parent is 2, and then we will tell him to further explore and find that whether this graph contains cycle or not. Let me run this code. Okay, let me submit this code. Okay, it has passed all the test cases. So one more reason is that one more thing I want to include is that I have run a for loop for checking this, just because of this test case. Because if the graph is not divided into components, then only writing here as 0 and comma -1 will traverse all the nodes of this graph. But because this is a component, so when we visit this component like 1 2 3, then still 0 will be remaining. Or if we start from 0, then this is the only component, like this is the only node in the component. It will check that okay, this is there is no cycle present in this. But what if in another component there is a cycle? So we will check that 1 2 and 3. So for 1 it is checking, for then 2 1 for 0 it is checking, then for 1 it is checking. Then if there is more component in this graph, so this will handle from this like line of code. Okay, so that is it for this video. Thank you.